Hi, fourth year. Hopefully you've had a chance to watch both the videos that I linked to the PowerPoint. They kind of give out a decent explanation of what the experiment is and gives you an idea of how the experiment can be run. What I'm going to do just now is I'm going to give you the notes that I want you to take and hopefully explain things a little bit further if you didn't quite understand it. So, new topic, Unit 2, Topic 3, final topic of Unit 2, energy from fuels. Nice short topic. Let's run through it. So, take the title experiment. Okay, so the amount of energy that fuels give off when burned can be determined experimentally and then compared. Okay, so normally you would do this with more than one type of fuel, and then you would compare your results and try and work out which fuel gives off the most energy. Okay. The following setup can be used, and then I want you to draw this diagram. So you've got your spirit burner with the fuel, your tripod, copper can, thermometer, and water. Okay, and the temperature of the water is measured before and after, and the change can be used to calculate the amount of energy the fuel released. Okay. Pause the video, take that note, and then unpause, and we will move on. Okay. So, several factors that can cause an inaccurate result, and it's important that we write this down because quite often, sometimes SQB will be like, why is this value different to the value that's stated in the data booklet? Okay, and the answer could be heat loss to the surroundings. There was little done to minimize the amount of heat loss that happens and naturally happens, but you want to try and minimize that. Okay, there's incomplete combustion. In order to fully measure the amount of energy that fuel gives out, you want it to fully combust. Okay, if you've got incomplete combustion, that doesn't give out as much energy as complete combustion. So if there's a lack of oxygen, then that'll give incomplete combustion, and the less energy there will be given out to the water. Okay? And the third one is just an incorrect setup. There's something about the setup that is wrong. Most likely, if the SQ asks you that, it's probably because it wants you to say heat loss or incomplete combustion. Okay? But there might be something in the diagram that it gives you that shows an incorrect setup. Okay. There are improvements that can be made to the experiment to minimize these effects. Use a draft excluder heat shield around the setup to minimize heat loss. Use a copper beaker as it conducts heat better than glass. So if you're using a copper beaker, the heat will be able to transfer to the water easier because that is a better conductor. Reduce the distance between the beaker and the spirit burner. So if you lower that beaker down, there's less chance of heat loss. Do not use a tripod and clamp the beaker instead. If you clamp the beaker, that means that the energy from the fuel isn't going to go into heating up the tripod to begin with. The heat can go directly into that beaker, into the water. So that's another improvement that can be made. And the last one, not often this gets mentioned, but you can stir the water so that an average temperature can be recorded. If you stir the water, that means that the heat gets dispersed evenly throughout the whole water. There's less chance of heat spots. So, if, for example, if you've got the spirit burner hitting one point in the beaker, that point can become a heat spot. That can become above average temperature to the rest of the water. So, if you mix that, you reduce that, you're more likely to get an accurate reading. Okay, so that's all the notes I want you to take for this part of the lesson. Go ahead and try the question that is on task 3. Take your time, have a look through the diagram, read through these notes that you've just made and see what improvements they have made to the bomb calorimeter to improve the experiment. Okay, and upload that to show my homework. I am about to record the notes for the second lesson. So by that point, you'll have been on a live, I'll have gone through the calculation, so it'll literally just be me telling you what notes I want you to take. Okay. Thanks, guys.